So, hello everyone. Welcome to this course. This is Digital Electronics and Microcontroller course at the UTC, the University of Tennessee at Chattanooga. And our students are preparing their projects, and there are very interesting projects that they can prepare. And today we will listen to two students, and Sawyer and Camron will explain about the half-life light MEMC, and they will show first the instrument that they developed, and later they will explain how they coded. Okay, your turn. Can begin now.
All right. My name is Sawyer Junkins, and I'm a senior in the mechatronics program here, and we are excited to share a project with you today.
I'm Camron Rockwell, and I'm a junior in the mechatronics program.
So just a little bit about how our presentation will go today. First of all, we have a project description, a parts list, a Proteus circuit, and then a demonstration of our project, an explanation of the code, some challenges that we faced during the project, and a conclusion. Here's a short project description. Today we have a walking cane with audible noise when approaching a wall or object. An interactive and practical approach that helps the user safely navigate the room or whatever area they are in. The buzzing sound is for the user to be alerted when they are approaching an object, and an LED is a visual sign for others around that the user is approaching an object. The distance that we have set currently is adjustable to where you can do it to where it's a larger distance. What we have here just works well with the ultrasound sensor that we have. And the height of this cane is adjustable, and on it, just a couple things. We have multiple sensors, an active buzzer, and an LED. So a little bit about how it works. Like I said, there are two sensors. There's an ultrasonic sensor and a touch sensor. And just pretty much how this works is whenever the user approaches an object or a wall or anything like that, anything that is in front of them or in the way, there's an active buzzer that will sound as well as a red LED. In order for the buzzer to sound, the touch sensor that is on here must be pressed, and the ultrasonic sensor must detect a wall or an object in front of it. If the ultrasonic sensor detects an object but the touch sensor is not pressed, the buzzer will not sound and the LED will not light up. Both of the sensors have to be signaled essentially to sound the buzzer and light up the LED. And so the way that we have it designed prevents the buzzer from sounding and the LED from lighting up if the cane is not in use. Whereas if it's like sitting on a table and the ultrasonic sensor goes off, but the buzzer won't go off because the touch sensor is not pressed, or leaning up against the wall or connected to power but not being used.
So just quickly, some of the parts that we were using. Obviously, we're using the Arduino Uno, and we used just a small breadboard for this. We tried to rig it all up on the Uno, but we just didn't have quite enough. I think we needed more voltage ports than we had, and so we just used the small breadboard and had a little sticky on it, so you can just stick it to our stick. Then we used the ultrasonic sensor and a 9-volt battery to power it, and we used an active buzzer and a red LED. And then we have just the touch sensor, or the capacitive sensor that just needs touch to be active, and then jumper wires of various types, obviously. And this is the Proteus circuit that we drew up, so we essentially just have power and ground to each of our sensors and our LED, and I think the buzzer also was to power and ground.
So all of this video was just a video of the device working, but that is something that I can show you right here, which we were planning on doing anyway. So as you can see, if the ultrasonic sensor gets close to something but the touch sensor is not pressed, it won't go off. If the touch sensor is pressed and you get close, then the active buzzer will sound as well as the red LED. And like I mentioned a few minutes ago, the distance for the ultrasonic sensor is adjustable to where you can set it to a larger distance, especially if you have a different ultrasonic sensor with a little bit more range.
This is our code for this. Basically, we set the pins to like the different pinpoints on the Arduino Uno. So we were just assigning those to the different sensors that we were using, and buzzer and LED. And then we're just initializing all of our variables. And then we were just setting our pins to outputs and inputs for all of our sensors. And then just setting up our high and low states to where the sensor will come on. If it's higher, it recognizes high and low to be on and off. And then we set our distance, and then just started up our loop, which we put an AND gate in there, so the distance has to be under, I think it was 5 centimeters, I think, that we used. And the current state, which is the capacitive sensor, also has to be on, which is high. And so those two together, and the buzzer will sound and the LED will come on, otherwise, or else, then they won't come on.
So just a few challenges that we experienced during the project. Like Cameron mentioned a few minutes ago, we didn't really have enough voltage and ground ports on the Arduino, so we had to expand and include a small breadboard. Altering the code when adding more sensors and outputs to control the system, and then going along with that, just a limited knowledge with coding. And then just some of the stuff with the Proteus circuit was kind of a challenge with some of the parts not being available in Proteus and having to line up the ports and wires to a dropped Arduino picture. And then just in conclusion, it is a simple but effective approach to a real-life situation using a cane with something that a blind person can use just to help navigate through a room or an area, and just using automation to help those a little less fortunate than we are, and taking what we've learned in class and applying it to a product or system with just coding, sensors, circuits, and total integration as a whole.
So, thank you very much for presentation. Applause, please. Okay, maybe can you show the parts here and explain which kind of parts you used for this project?
So right here you just have the ultrasonic sensor. Here you have the Arduino, the small breadboard, the 9-volt battery, the touch sensor, the active buzzer is right here, and then the red LED is right here.
So now your turn, and please ask questions to your friends now. Johan, we are beginning with you.
What are the benefits of having a touch sensor rather than an on and off switch?
So an on and off switch would work. And the reason that we went with a touch sensor is just to where your finger has to be on it. Odds are your finger, like nothing will be hitting this touch sensor and setting off that ultrasonic sensor. And so like I mentioned back like a couple slides ago, it's leaning up against the wall or sitting on a table, and if it gets accidentally clicked on or anything like that, to where it won't go off. Whereas with this, your finger has to be on it in order for it to go off. So where it's just more, I guess, safety, if you want to call it that, or just where it won't go off at unwanted times.
Thank you. What else? Wilhelm, first you, then
So I know
Michael.
the actual walking canes that blind people use are collapsible and they're relatively lightweight. So how compared to that, like lightweight and collapsible, could y'all make y'all's model? I know that one's definitely a prototype.
I imagine you could get better like the ultrasonic is a pretty large sensor. I feel like they probably make smaller sensors like that. And there's probably a way you could integrate it like into the core of the cane. That way it would be kind of, you wouldn't really notice it. And obviously that cane is a little bit large too. But yeah.
Okay, Michael.
So what kind of parameters did you guys test with the ultrasonic? Like how far away did it work well? How close did it not work well? That kind of thing. And did you guys fool around with trying to put maybe a potentiometer on it to control the distance variably?
The potentiometer, no, we did not do that. When it came to the parameters of the distance with the sensor, we didn't play around with it too terribly much. Probably, realistically, not as much as we should have. The little bit that we did, it got to a point where it wasn't, to where the buzzer on the LED, to where it was more of like a flicker and it wasn't a constant sound the further away that we got. And so like once it got to a certain point, it really just didn't function as well as we would like it to. So we decreased it down to what we have it at now, which helps for more of just like a constant sound.
So did you guys have it to where it would sound only when a certain like centimeter away hit?
Yeah, so the way we have it set up now is to where like once it gets to a certain distance, to where like now
It stays on until it clears off?
pretty much, yeah, and it was 10 microseconds for like as long as it's hitting, pretty much.
Are there other questions? Noah, your turn.
If a blind person's using the cane, do you guys have like a system in place to let them know if the battery were to like run out of voltage? Because they wouldn't be able to know if it stopped working if the battery runs out. Like, would you be able to set up like a sound system to let them know that the battery's low? Or do you have that in place already?
Yeah, so we don't have it in place right now. However, I would imagine that's something that could be added on there, is some sort of something to read the battery life left, and once it gets under 20% or something like that, to make an audible sound that is different from the active buzzer on there to alert them that the battery is getting low.
Right now, I guess they probably just want to test it before they start it, just put their hand there or something, because there's nothing else that we have right now.
Johan, do you have additional question?
Just one more question. How durable is the stick overall and the components? Because I do have a family member that is blind, and they have a lot of walking sticks, and they're all pretty banged up and scratched up because you have to use it to feel everything around you. How would it compare to other walking sticks?
So the actual stick itself is fine. Now the way that we have the components on here right now, it would not be able to withstand a lot of damage. This is, obviously more of a prototype sort of deal than anything, and so now it could definitely be constructed in a way where it could withstand significantly more damage than it's set up right now.
Other questions? So thank you very much again for the presentation. You prepared very nice, and I would like to have your PowerPoint slides later with the video, and I will upload these videos into YouTube. You can watch later there.
All right.
Okay. Congratulations again.